Hello, hello. So this training, it's not training actually. I'm just copying another person's post, Tom Measure Antonsen. So I see him posting his, ladder program or STL program, a part of his book. He has written a, I would say, very good book on automation and PLC programming. But I would pick up some of his post and go through it. If he has done something that can be improved, of course, this training, his book is actually basically to intend to give basics of PLC programming. It's not advanced, so we can actually go through it, how easy or how difficult and things like that, using actual software. So you see him posting part of his page. I will maybe go through his pages and do it using the software like TI Portal. So I have the TI Portal opened, and let me go through what he says here. Okay, so here he says that it has conveyor belt application, and this conveyor belt actually for pallet transportation, and this can be started using start push button and stopped using stop push button. And then while the pallet is loaded on top of this conveyor, a limit switch B1 can be activated. So when that B1 limit switch activated, this conveyor also should stop. And then the pallet will be manually transferred or removed. And when the limit switch is no more activated, because the pallet is not there, the conveyor belt should move forward again. So this will allow the next pallet to come in, and that we were operating the this what is called pallet forklift truck. He can continue unloading the remaining pallets. So that's the application goal of it. Hope you can imagine this like pallet forklift. Let me forklift pallet transport. Okay, so if you search this application, what we can get actually, let me go to image or image. Yes, so you see this pallet transport, or it's not actually proper. We cannot actually get the exact application what he has mentioned in the image with this the limit switch and so on. Obviously there is some application that limit switch can be used, but I do not find anything with that such thing. Let me be clear, or we can actually imagine something like a forklift which has a conveyor belt and it has a limit switch. So forklift with conveyor belt and limit switch, and then driver who is driving the thing, he has a push button, two push buttons, start push button and stop push button. So he is operating maybe this guy. He has start push button and stop push button. And then the conveyor belt, maybe something here, it is installed and it will move down. This, if we conveyor belt rotate like this, the material on top of this would go up to the limit switch. When it hits the limit switch, it will stop. So the operator will unload the material, but again, it can hold only one pallet at a time, right? So it's not proper example actually. So it seems like the application has the conveyor is long and it can have multiple pallet on top of it. So let me pallet transport conveyor belt. So we can, yes, maybe this one we can understand something like this. Okay, we can get something like this. So how we can use this? This also cannot be used, because if you see, if the conveyors, this is the conveyor, right? This is the conveyor moved down to the forklift and it hits the limit switch. This conveyor stops, and if he unloads to somewhere else, this limit switch will not be anymore, activated. So this conveyor will kind of start again. It may fall down. So this is not the proper application as well. So where does he get this application and applicability of this example? I do not get it. Let me find something else. This one, X-ray machine is checking X-ray machine. Don't know. This is not applicable there as well. This one, it has pallet IC. So yes, so pallet unloaded. Not right. This one, no. Which one you think is suitable for this example? Okay, so only thing is we can use the imaginary power of ours and then do the programming. So this is kind of, let's say, conveyor belt. We create one application and TI portal and see how to do this in actual Laravel. We are starting the TI portal, opening a new project. I have given a name, conveyor belt, to the TI portal project name, and let's see. So now the project has been created. It's stored here. This is the location of the thing. Conveyor belt was successfully opened. So that means the project also open. So we can go to the project view here. Okay, and then we can add a device. Device means here the PLC. Okay, what PLC we can add? This is a very simple application. We can add any PLC we want. So let me add a standard PLC. Since it's not found. So you see the license got trouble. Let me get some license of this. Where I get, I need to close it again. Okay, so here I cannot find any license. Let me go to my PC. Actually, I just installed the software. Maybe I use only 1 week, but anyway, I can get the working license for this. I'm not sure if you can find the license for version 16. Okay, professional one version is there. You see this one, this also 16. So I have installed here portal version 16. So for that too is found. So let me select this and select this and then install. So I have installed this long version and then select this, install short version as well, and that's it. I have to now find the install key. Install key is installed. There's 3 versions, so this is a flexible. Let me see another thing. PID, this one also can be used. Safety, this one also flexible. RT, professional. These are the thing I can actually install to use later. Web monitor, web operate. This is different version. I do not need. 16 all I had selected, and then 16 OPC server, safety combo. Okay, so let's install all those. Override it. Okay, so I have now so many license already installed in this PC. I should not be problem anymore with the license. So close this, open TIA portal. It's administrator. Open this project again. Go to project view. Okay, try again. Open, insert new PLC into the project and select this CPU. Maybe this one. You can choose the latest version and select OK. So now you see we do not face a license issue. Our license is activated and we can use TIA portal. This license, of course, you cannot use for production in real manufacturing plant or process. This is only for training purpose, and it's used for many professional, for testing and trialing and things like that. Even system house uses this license. So that's it. Now, if we see our requirement for what is called this one, what do we need? We need one output per motor to rotate the conveyor, another limit switch to stop the pallet, push button to start and push buttons to stop. So how many inputs we have? We have 3 inputs, 1 output. That's it. So 4 IOs what we need to define in our project. So we need, of course, a IO card because this does not have any onboard IO. You see, it has interface, 3 interface, Profinet 2 interface, 1 Profi bus DP interface. To insert IO, input and output module, you have to select this PLC, go to the hardware, go to the DIDO, because we do not have analog input, we have only digital input and output. So this one is good start. So we have a standard DIDO, and select this and select that slot that is compatible with this module. So these blue rows means this is compatible. We can insert here. I think we can also insert that. Let me delete this and see again. Delete this and show you again. This is slot number, you see, highlighted. So that means this slot and this slot are same. We can insert anywhere you like. So you can insert here or here. It's better to not keep empty slot. So start from the left to right, and that way you don't keep any empty slot there. But if you want, you can keep empty as well, because the backplane bus can communicate. Now we will open this, double click on it or right click on it, and then go to properties here. You see this one, it's already open. And this IO tag, you can name some IO, like one input is push button 1, this is stop, and then push button 2, it is start, and then limit switch LSW1. So 3 input we have already configured, and this is storing in our default tag table. You can change the tag table by here going to PLC tags and default tags, right? So if you want, you can create new tag table, name it something like conveyor belt. So this table related to conveyor belt, not here, sorry, here. Right click, properties, and give a name to conveyor belt. That's it. So now if you go to the same PLC here and then select conveyor belt, want to store the IOs tags that related to conveyor belt into the table conveyor belt. So this is motor conveyor belt. Okay. So this is going to be output, and we do not want in here. We cut here because we do not need this. It should be here, output conveyor belt. Again, we select the same belt, conveyor belt. Now if you go open this conveyor belt table, you see we have 4 input and output, 3 inputs and 1 output. And these are the properties access from where HMI, right from HMI. So this tick means it allows to communicate with HMI software. Visibility is for visibility in the HMI engineering station tag. So if you use this two, of course you have to better select this also. This is supervision. We will talk later. Supervision. That is supervision. Okay, so this is done, and we have to go to now software programming block. And this one we're not talking yet. We directly go to OB1. This is simple program, so we don't create any function block or function. When we need, we will create, of course, those function block and functions. But here it says when you start, let me go open for you that program. This is the program, right? So now it's opening his Facebook post, and it says the conveyor belt for pallet transportation can be started by push button, stopped by another push button X2. You need to understand the start push button is normally open and stop push button is normally closed. Considering that you know that basic concept, we would do the programming. And then conveyor stops when B1 limit switch hits with the pallet. Start again when the pallet removed from the conveyor. Okay, so in this example, I would present something like better this example maybe. So it's like the pallets are coming from different location, and the conveyor is moving and bringing these pallets into nearby the forklift. Okay, so what is happening when he starts? It starts the conveyor until a package or pallet hits a limit switch, then it stops. Okay, so manually one person remove that pallet, okay, into and load into the forklift. So when he removes that packet or pallet into the forklift, that limit switch is not hitting the pallet anymore, so it allows the conveyor to move again. That means start again and bring another pallet and hit that limit switch. So when the pallet hits the limit switch here, maybe it is installed, the attending person again, he unloads the pallet and put it in the forklift here. Okay, so when he removed this pallet, the limit switch release again, so conveyor start again. So this is, I think, better example than what he has drawn there. So the person here, maybe it has a start push button and stop push button here in this platform only. And then forklift has nothing to do with the conveyor in this case. Forklift has a driver who will, when it is fully loaded, he will pick up this pallets and go and store somewhere else and drop somewhere else and come back again. Okay, the operator again remove one pallet from the conveyor belt and put it in the forklift. Hope you understand this concept. So this is kind of application. I would say copy image URL. Okay, I have copied this. Maybe I will put it somewhere in this example and remove this, and maybe I just insert this here. Oh, so big image. Okay, It's not very good. I just told you what it is, and things would be easy enough. Let's do the programming of it. In this portal, what we have to now learn is we have to start the conveyor. Okay, so we have given a name something like pp1, pp2 for start, and then we're going to stop the conveyor when this is going to be start. So here we will use conveyor belt. So starting will start the conveyor belt. Okay. We do not want actually directly to use this conveyor belt at this moment. We can use a flag. For example, we want to use 1.0 as a intermediary flag that would say kind of operator start. Okay, so it is kind of let's create a tag with that name, operator start. So operator has pressed the start button, and that we are storing somewhere. Okay, so this one is operator starting conveyor belt. Now, if what is called if the limit switch is there, limit switch is there, or sorry, PB1 stop push button is pressed by operator, stop by operator, then it will actually reset that flag. So we use that again here, reset the flag, and that is what he used in his example. Or it says stopping by operator. So starting and stopping the this flag. But there is another output we have to use is real conveyor. We have not used that conveyor belt output. So conveyor belt, to turn on, the limit switch must not be there. So it's like limit switch should not be activated. LSW1 should not be activated. So you see, when it is activated, we use something like this. When we activate, then thing happen. So result of logic operation, RLO of this, normally if we don't press, it's a 0 here. But if you press, then we get 1 here. Something like this, limit switch is not activated. Is not activated, is the opposite of that kind of thing. But again, I will tell you about something, this one. The stop switch also normally close. Okay, so it's always activated by default. When operator actually press the limit switch, it is not activated, kind of break the circuit, and that's why we use for stop something like this. So activating the stop switch actually breaks the circuit. That's why we use something like this, not opposite of that start push button. When start push button activates from outside, it is actually normally open and then connects the circuit. And this one, when activates the limit switch, it was normally closed. After pressing, it actually breaks the circuit. That's why we use this circuit. So this means actually when the circuit is not, the PLC is not getting the input, then we use this one. And this one we use when the PLC is getting the input after we press the push button. So we start this flag, and then when operator breaks the stop button connection to the PLC, we actually reset that flag. And the limit switch when not activated, then we run the belt, but we have to check whether operator has started the conveyor or not. We have to make sure that operator has already started the conveyor. Then we run this motor conveyor belt. Okay, so this is so far very good, I would say, simple program, and we can use this in another way if we want to use that latch technique. Let me open another function here, conveyor belt. We can also do the same programming here, something like start, and then stop VB2. Oh, sorry, stop. Then here we can use that motor conveyor operator start. Sorry, operator M1.0. I have already changed this name, tag name. I didn't change actually. Okay, so I have used the local tag. This I should name it. Let me rename it. Operator has started. So this bit turns on when operator has started the conveyor belt, and then here we can actually latch this start push button. This is I think one of the most popular program in the training. We use the same flag to actually teach about the scan cycle, and here it goes. So in the first scan cycle after the operator has pressed the button, the stop button is already connected to the PLC, and so it gets this Mercury M1.0 bit turn on, and the next scan cycle, when operator has released the start push button, it actually latches with this status of this one. It's a software, amazing that software can do this. So starting or setting a flag for conveyor. So this is a flag for conveyor. Okay, and then we use this flag. So you see we have not used the what is set reset flag. So after operator has started this flag, we use this thing. We use this here and check the limit switch. If the limit switch is not there, LSW is not there, then we actually start the motor. The motor is a conveyor belt. This output Q0.0. We do not need every for this program because we are directly using the addressing. It's like that. We can use this program, but okay, this one has to be changed. Local, we cannot use local variable for this position. This one and this one has to be replaced. Okay, and then local variable created in OB here. We do not need this. Delete it. So you see, we can use this program directly within the OB1, or we can call that FC1, FC1 conveyor belt, this one. Directly call this block. either one, you do not use both. Delete this part. Okay, maybe you delete something like this. So what he has in his Facebook post is also a good program, but this is also a good program. In to network, you have this done without set reset instruction. We have this program ready. So that's it. I hope you liked it, and let's go to the Facebook post of his. So you see he has 3 network in his program, and I have used only 2 network without set reset instruction. But if you count the number of instruction, so it has 4, 5, 6, 7 instruction used, and then I have here 1, 2, 3, 4, 5, 6, 7. This is total same number of instruction element, ladder elements are used. So what do you think? Which one is going to perform better with speed and things like that? Let me know with your like and comments.